Chapter 1, An Introduction to Functions. We start with the definition of a function. A function is a relation where every input has one specific output. When we use the word input, we're referring to the x values, and when we use the word output, we are referring to the y values. There are two different ways that we identify if the relation given is actually categorized as a function. The first way is algebraically. So we can take values for x, we can plug them into the equation, which is our relation, and solve for y. When we solve for y, if we only get one output, then our relation is a function. If we solve for y and we get multiple outputs, then our relation is not a function. We can also solve graphically, where we can take that relation, we can graph it, and we can use a vertical line test. Let's look at some examples. Example 1. Determine whether or not the following is a function. So you can see that we are given an actual graph on the right hand side. So I'm going to use the vertical line test. When I use a vertical line, and I know that these are not perfect vertical lines, what we're doing is we're trying to identify how many times does the vertical line actually touch the relation. As long as there's only one point of intersection for each vertical line, then that means that we can identify and name the relation a function. We can do the same thing with example B. We're going to draw vertical lines. The very first vertical line, you can actually see that for this given value of x, and let's just say for example that this is x is equal to -1, we have two different points of intersection. That means that at each of these points we have different y values. So when x is equal to -1, we have a y value. I'm going to identify that as y sub 1. And up here, when x is equal to -1, we have a separate y value, meaning that we have two different outputs. So therefore, this is not a function. Now the one thing you have to know is that you can actually draw a vertical line and have it intersect in one spot at one point in the relation, but as soon as there's another spot that has 2 points of intersection, it is now not a function. We approach example 1c the same way. We draw our vertical lines. My first vertical line, I have 1 point of intersection, so one output for the input. Same with my second vertical line, my third vertical line. So far we're good. This is a function. And then when we get to this green line, when x is equal to 2, although it may appear to you that this actually has 2 points of intersection, it is not true, because on this upper line we have a closed circle, so it is including, so that's our first point of intersection. But then when we go through the second line, it's an open circle, so the graph is actually not defined in that specific spot. So we're still okay on this green line. We still are passing the vertical line test, and it's still a function. So overall, for 1c, we do have a function. So the specifics here is that we're looking at when x is equal to 2, it appears that the graph is touched twice, but with the open circle and closed circle, that is not true. Now what if we're given a table of values? What we're going to do is we're going to identify, do we have any inputs that pair with multiple outputs? Well, you can see that all of our inputs are different. In order to have multiple outputs, we would have to have an input that is duplicated. You would not see any dots graphed that didn't pass the vertical line test. So therefore, this is a function. With our next example, when you look at our inputs, you'll notice that we have two inputs that are repeated, and they are mapping to different numbers. So that means that this is not a function. We have one input, which is x is equal to 8, and it is mapping to two specific outputs. Now we're looking at coordinates. We've identified here that we have two x values that are the exact same number, so those are our inputs, but yet notice that they have different outputs. So this is also not a function. Function notation is a term that we use to define relationships between our x's and y's, so our independent variables and our dependent variables. It gives the function a specific name, and it is read f of x. So instead of having y is equal to 3x plus 1, this is a line. A line, unless vertical, passes the vertical line test. So we can actually change this to be called f of x is equal to 3x plus 1, because 3x plus 1 is a function. So it's just a more specific way of defining that relationship between our x's and y's. You will be asked to evaluate functions. When you're evaluating functions, what you're doing is you're looking at what is inside the parentheses next to the f. In the original question, it's an x, and you'll see that you have x's on the right hand side as well. In the question, this x has changed to be a 3a. So if x has changed to be 3a, and x is equivalent to 3a on the left side of the equation, the same has to be true on the right hand side. So each x is going to change to a 3a on the right and left hand side, and then we will simplify to evaluate. So this first step shows that I removed the x from the left and the right hand side, and I replaced all of them with 3a. Then I'm going to use my order of operations. So I'm going to apply the squared first. So I'll leave this 2 out front, and I end up getting 9a squared. I'm going to multiply, and then I have the plus 4. Then I'll distribute, so I have 18a squared minus 9a plus 4. And that is my simplified evaluation of the function. For example 2b, we're asked to evaluate the function again, but this time the x is changing to an x minus 3. So I'm going to start by changing all x's to become x minus 3. So as you see in this first step, we have x minus 3's. We're going to start with the squared. Now this is a binomial, two terms, so that means that we have to make sure that we FOIL properly when we expand. We get x squared minus 6x plus 9. I'm going to distribute the negative 3, so negative 3x plus 9, and then carry the 4 down. Then we can distribute the 2. We get 2x squared minus 12x plus 18. And I'm going to collect like terms with the 9 and the 4, so we get positive 13. And then collect like terms again. 2x squared, negative 12x, and negative 3x is negative 15x, and then positive 31 for our final answer.